This conference will now be recorded.
Okay, good afternoon, students. In this today's class, we are going to discuss about transmission loss formula. So, what is the main intention of this formula? Means till now we derived three derivations how to schedule the power plant. But so that is the case. We can't able to reduce that. What is the losses happening in the transmission line? Just we found that based on the given problem and what is the power losses will be happening when the power generation schedule is happened. But in today's derivation, we are going to derive the power loss equation, that is a transmission loss equation with respect to the loads and how much of generation is generating from the plant and what is the power should be delivered to the load. And between that, how much of losses will be happening. So this type of things we are going to discuss in this today's class. So let me go to the topic. Say wait for a few minutes. Most of the people didn't came. So this is the topic we are going to derive in today's class. That is derivation of transmission loss formula. So what is the main intention of transmission loss formula? Means we derive that we derive the third method of scheduling method. We are including the losses, right? So in that, what are the different ways of for calculating the power loss equation? So already we discussed in that. So we are applying the power loss equation, and it consists of a B coefficients, and it's called as a loss formula or Kranz formula, right? So from that formula, we derive that what is the power loss equation. Power loss will be happening after that power loss value. We are substituting the balanced equation, energy balance equation. After that, we can updating, keep on going to find that updating the lambda value. So that process will be continuing that when that power balance equation should be equal to zero. So that is the thing we derived in previously. But in this derivation, what we are going to know means generally the power should be transmitting in the transmission line in the form of real and reactive power. But if the losses will be occur, that is in the form of real power. But the rectification of losses, we have to how we can rectify the losses means by injecting the reactive power into the transmission line. It means that the losses will be occurring in the real power, and for minimizing the losses, we have to inject the in a reactive power. So that is the thing happening in the current transmission line system. And let me see that how can you determine that what is the real power loss is happening in a particular bus, and how we can stabilize that losses by injecting the reactive power in a particular bus. Let me go for. So this is the similar to what we discussed in that in a power system analysis. So in that we are finding the Z bus, Y bus, right? For particular bus Z1112. So same thing we can see here in this derivation also. And it consists of approximately 30 equations. Just keep remember that. See here, that is already I said that the major steps of optimal disk of generation is to express the system losses. So we have the three scheduling methods. In the three scheduling method, the first one is normal tradition method, and second one, third one is analytical method. In that analytical method, the second one is we are not including the losses. So it is the negative losses we are considering here. And in third one, we are including losses. So while including the losses only, that we can know that how much of power we have to generate and how much of power we have to deliver to the load, and what are the losses will be happening, how much of losses will be happening thus while delivering the load, while delivering the power from generating station to load. So this is the most steps we are using in scheduling process, that is the thought method. And in that, what we have to know is we have to know the power loss equation. And this power loss equation we can obtain some different methodologies. But in this subject, we discussed this power loss equation by using the Cron's method, and it is also called as loss coefficient or B coefficient. By using this method, we derive the we used the power loss equation. From this power loss equation, we found that how much of losses will be happening based on this scheduling process. Now, generally, let me consider that we have number of buses, 1, 2, 3, and so on. We have m buses. Now, if I inject in the if the at ith bus, what is the total injected complex power? So it is denoted by SI. So yes, is here this is the power denotation while injecting the transmission line. So it is a complex form. And PI JQA. So PI already know that real power, reactive power. Here I can write this equation, that is a power. So if it is in the complex form, it is conjugate form. So I can write in the form of VI. I can write V at ith bus and I capital I for at ith bus. So why I am using conjugate here means in that condition the load, when the changing in the load is completely depends on that how much of current is delivering to the load. So that's why the change in current will be happening here. That's why I'm applying the conjugate here. So this is the equation one. So the equation one is given by that we are injecting the complex power at ith bus and it is denoted by SI. So just write down the equation, then only you can understand the step by step. ఎందుకంటే మనకు డెరివేషన్ లో సబ్స్టిట్యూషన్ జరుగుతాయి. సో ఫస్ట్ ఈక్వేషన్ నుంచి 13 ఈక్వేషన్ ఆ విధంగా వచ్చినప్పుడు మీకు కన్ఫ్యూజ్ కాకుండా ఈక్వేషన్స్ అన్ని నోట్ చేసుకుంటూ వచ్చేయండి. So this is the first equation, and this equation has to be used to find the transmission loss formula. Right. Now, the summation of powers of overall buses gives the total system losses. So why? Because previous one we are finding that formula at ith bus only. But if it is ith bus, we can use only we can calculate only losses in the ith bus. But if you want to find that losses in the entire term, we have to conjugate. We have to consider that. We have to use that all parameters for all buses in the system what we connected here. So this equation can be written as PL plus JQL. That is the last formula for last power in the form of real and reactive is equals to. So here I'm considering that our total number of buses here, right? And in this equation, if you consider this VA and IA conjugate, these two are in the form of vectors. Vectors means we have to solve this every equations in terms of matrix form. Then only we can. So matrix form we can V1, V2, V3, and Z11, Z12, Z13, Z21, 22, 23. Similarly, I1, I2, I3. Now here V and I both are in column vectors. So if you write in the form of V is equals to IZ. So for writing the number of buses, you can write V1 to Vn. Similarly, I1 to IN. After that, Z11, Z12, 21, 22, like that you can write that. So here, while observing this equation, the voltage term and current. So both are in column vectors. So see here, this is the parameters involved in the equation 2. This PL is a real power loss, reactive power loss, and V bus is a column vector of the nodal bus voltage. It means that from the nodal analysis, we can always suppose this is the main feeder and it is the sub feeder, and we have to always concentrate on the node voltage. See where the voltage should be available. That is the node. So that's why it is called as nodal voltage. And I bus is a column vector that is injected to the injected bus currents. So these are the four parameters when we represent in the form of real power, reactive power in terms of voltage and current. Now, this expression for the bus currents in terms of bus voltage. So already we have the two equations in terms of current and voltage by using that admittance bus, impedance bus and admittance bus. If you know that admittance bus, you can use this equation 3. If you know that impedance bus, you can use that equation 4. So this is the two equations for identifying, for calculating that what is the current is injected into the bus and what is the voltage available at the particular node. So let's consider this is equation 3 and equation 4. Now, the inverse of bus admittance matrix is known as bus impedance. So the bus admittance matrix is non-singular if there are shunt elements are connected to the graph. So when it is called as singular and non-singular, anybody can say that when it is called as singular and non-singular. So మనం ఆల్రెడీ చేసాం కదా సింగులర్ ట్రాన్స్ఫర్మేషన్, నాన్ సింగులర్ ట్రాన్స్ఫర్మేషన్. When the bus admittance matrix is called as non-singular. Right, leave it. No problem. So now, so here the bus admittance is a non-singular. If there are, why? Because the shunt elements are connected in a graph. Okay, now ఎందుకు non-singular అంటే if you are connecting the shunt elements, so singular in the sense that there is not chance to get the changes occurring here. So if you connect any series elements in the connected graph, so you can't able to. So if you remove that series element, then it makes a open circuit. Okay, now open circuit అయిపోతుంది. So that's why if you are connecting that shunt element, it becomes non-singular. అంటే non-singular అంటే ఏంటంటే the size of the bus system should be keep on going to change. అంటే ఒకసారి ఇంక్రీజ్ అయినా చేయొచ్చు, డిక్రీజ్ అయినా చేయొచ్చు. దాన్ని నాన్ సింగులర్ ట్రాన్స్ఫర్మేషన్ అంటారు. ఓకేనా? So ఇప్పుడు the equation 4 substitute in equation 2. So what is the equation 4 and equation 2 is? So this is the equation 4. Now this equation 4, if you substitute in here, that is instead of V bus, so you can substitute Z bus and I bus. So let me see what we'll get. That's right. So instead of by using the equation 4, substitute in equation 2, that is V bus is equals to Z bus into I bus. If you substitute here, then it will becomes like this. So I'm applying that transformation. So finally, PL plus JQL is equals to I bus transpose Z bus transpose I conjugate bus. So let's consider this equation 5. Now there is a one condition for the symmetrical matrix. For symmetrical matrix, suppose can you give the example for symmetrical matrix? What is the example for symmetrical matrix? Anybody? What is the example for symmetrical matrix? Right, unit matrix. So unit matrix is only symmetrical matrix. Why? Because I will show you how it will be possible. 1 0 0 1. If you apply the transpose, you will get same matrix, right? So this is the condition. When the Z bus is symmetrical matrix, then you will get like this. Okay. So symmetrical matrix eppadu when you are considering that mutual impedances value. So mutual impedance means only the corner values, dimension values, right? So at that condition, you can get that this, you can satisfy this equation is 6. Okay, now, so this is the condition satisfied when Z bus is equal to symmetrical. And up to now, sixth equation, we found that in this sixth equation is substitute in this fifth equation. Substitute equation 6 in equation 5. So if you substitute here, what you will get? PL plus JQL equals to I transpose bus Z bus I conjugate bus. Right? This is the equation that was to be injected to the complex power in the conjugate transmission line. Right? From this equation, let me see that how we can expand this equation when we after substitution of 6 in 5, what will happen in this equation. So here I am substituted equation 6 in equation 5. After that, instead of Z bus transpose, it becomes Z bus. Now, this above equation can also be expressed in induction notation. So induction notation is nothing but a PL plus JQL. So this one term is for real power bus, and the second one is Z11. So actually, this is if you want to find the matrix, you have to write in the form of Zij. So Zij చేస్తే మనకు Z11 ఈ విధంగా మ్యాట్రిక్స్ ఫామ్ అవుతుంది. So for the matrix, we have to represent the equations 7 in the induction notation. So ఈ విధంగా ఇండెక్స్ నోటేషన్ అంటారు. అంటే ఇంపిడెన్స్ మ్యాట్రిక్స్ ని ఐజే ఫామ్ లో రిప్రజెంట్ చేస్తారని ఇండెక్స్ నోటేషన్ అంటారు. ఓకేనా? సో ఇప్పుడు ఆ పవర్ ఈక్వేషన్ ని ఇఫ్ యూ వాంట్ టు మేక్ ద ఇంపిడెన్స్ మ్యాట్రిక్స్ ఇన్ టర్మ్స్ ఆఫ్ ఐత్ అండ్ జెడ్. ఓకేనా? సో అంటే 2 పాయింట్స్ మధ్యలో ఎన్ని బస్సెస్ ఉన్నాయి, ఆ బస్ యొక్క ఇంపిడెన్స్ వాల్యూ ఎలా. So this is the final IJ. So from 1 to n, like that. Okay, now. So since the Z bus is a symmetrical matrix, so here also we will get Zij equals to Zji. So up to this equation 8, this is the equation 7 we got after substitution of 6 in 5. And if the equation 7 can be represented in the form of index notation, you will get like this. So the representation of Z bus in terms of Zij, for formation of Z impedance matrix, then it is called as index notation. Now in that Zij, so impedance is the Z bus is a symmetrical, right? So in that Zij is equals to Zji. It means Z12 is nothing but like Z21. So it will happen in only symmetrical terms, right? Now the equation 8 can be expressed as. So ఇక్కడ వచ్చేసి now here it is the ith bus, it is the jth bus, so right? So now for forming the ij, I am separating this for 2 ij and ij. So if you write this, then you will after solvation of this equation you will get same equation 8. But simplification for separation of these two, then I can express the equation 8 can in the form of equation 9. Okay na? So ఇక్కడ చూస్తే మీరు this is the I and ij. So once I am applying ij conjugate for the ij, and here I am applying the conjugate for I. సో ఇలా ఈ విధంగా చేసినప్పుడు ఏమవుతుందంటే Zij కెన్ బి అప్టైన్డ్ ఇన్ ఈజీ మ్యానర్, అంటే త్వరగా మనం అప్టైన్ చేయగలుగుతాం. ఓకేనా? సో దట్స్ వై ఐఎమ్ సబ్స్టిట్యూటింగ్ దట్ I ఇంటూ ij కాంజుగేట్. సో దీన్ని ఎక్స్పాండ్ చేస్తాను ఈ విధంగా ఫర్ అప్టైనింగ్ ద Zij మ్యాట్రిక్స్. నెక్స్ట్ see after so here I'm expanded that 2 terms. Now from this so this entire term is a combination of real value and imaginary value. Now I want to split up this real and imaginary value, then only I can calculate. So మీరు Gauss seidel method లో q value కనుక్కొని చూసారు అంటే for load bus. So in load bus you don't know the value of q. So if you want to find the q value, we have to separate that real value and imaginary value, right? The same thing if you want to find that real power and reactive power, that is the. So why? Because the losses in the form of power, But here the power is it is a combination of real and reactive power, right? We should have to separate. We should have to calculate that, separate them. How much of real power is losing? How much of reactive power is losing? So that's why I am separating this equation 9 in terms of real power and reactive power. That is real and imaginary components. So if you split up this 9 in terms of real and imaginary, you will get like this. Just note down these two equations, equation 10 and 11. So how we will get this means these two equations. Generally, what is the formula for Z? R plus Jx. So here for real term having that R and imaginary term having that X. So that is the thing here. See, after note down this equation, just we consider that real power alone. If you consider real power alone, so this equation will get. సో ఇక్కడ వచ్చేసి మీరు ఈ టర్మ్ ని ఎలిమినేట్ చేస్తాం. సో దెర్ ఇస్ నో, సో ఫర్ బ్యాలెన్స్ పర్పస్ వి కన్సిడర్ ఇన్. సో ఇక్కడ మనం ఎక్స్ప్లెయిన్ చేస్తాం, కానీ మనకు ఇది అవసరం లేదనుకుంటే వదిలేయచ్చు. సో జస్ట్ వీ కెన్ యూజ్ దిస్ టర్మ్ అలోన్. సో ఇప్పుడు దీని ఈ విధంగా చేసినప్పుడు ఏం చేస్తుంటే, సో ఆల్రెడీ మన ఏ స్టార్టింగ్ చేస్తాం, జెడ్ బస్ కెన్ రిటర్న్ యాజ్ జెడ్ ఐజ్ ఫర్ ఇన్ ఇండెక్స్ నోటేషన్. ఓకే, ఇండెక్స్ నోటేషన్ లో జెడ్ బస్ ని జెడ్ ఐజ్ రాసుకున్నాం. బట్ జెడ్ సో జెడ్ వాల్యూ ఇస్ అ కాంబినేషన్ ఆఫ్ real and imaginary part, right? But I am considering only real part. So z bus z is equals to r. సో మనం జెడ్ బస్ ని జెడ్ ఐజే రాసుకున్నప్పుడు అలాగే ఆర్ బస్ ని కూడా ఆర్ ఐజే రాసుకోవచ్చు. వై? బికాస్ ఆర్ ఇస్ ఏ రియల్ పార్ట్ ఆఫ్ జెడ్ బస్. ఓకేనా? సో ఇప్పుడు నేను ఆర్ ఐజే ఉంది కదా, దీన్ని ఆర్ బస్ గా రాసుకుంటాం, వేర్ ఆర్ ఇస్ ద రియల్ పార్ట్ ఆఫ్ ఇంపిడెన్స్ మ్యాట్రిక్స్. ఓకేనా? సో దిస్ ఈస్ అప్ టు దిస్ 13 equations are over. జస్ట్ నోట్ డౌన్ దిస్ ఈక్వేషన్. సో ఇక్కడ ఒక్కొక్క స్టెప్ డిఫరెంట్ ఈక్వేషన్స్ ఉంటాయి. సో స్టెప్ బై స్టెప్ ఈక్వేషన్స్ ఉండవు. సో ఒక్కొక్కసారి ఒక్కొక్క ఈక్వేషన్. సో మీరు ప్రాక్టీస్ చేస్తే మీకు గుర్తుంటాయి. యాక్చువల్గా ఈ డెరివేషన్ వచ్చి 2 classes పడుతుంది. సో ఈ రోజు వరకు మీకు హాఫ్ డెరివేషన్ చెప్తాను, రిమైనింగ్ వెబ్ క్లాస్ లో కంటిన్యూ చేస్తాను. సో టెల్ మీ ఆఫ్టర్ కంప్లీషన్ ఆఫ్ దిస్ ఈక్వేషన్. Right. So until now, first we found that Z bus from the given data. In that Z bus, we are taking only real parts, that is Rij. After that, we have to find that what is the current with respect to the generating to the load. So we have to find that, we have to calculate the current. Okay, so 13th వరకు మనం Z bus ను ఫామ్ చేస్తాం. Z bus నుంచి only real part కన్సిడర్ చేస్తున్నాము, that is called as R bus. Now we have to calculate that what is the current is injected to the load. సో మనకి లోడ్ వచ్చేసి డిఫరెంట్ కండిషన్స్ ఉన్నాయి. అంటే the load should not constant. It has a different. So some loads requires current I1, some load requires current I2. So finally the total current demand is ID. So the sum of all currents is equals to ID. So from this equation we are going to derive that what is the I bus matrix we will get. Now see here, in order to obtain the general formula for the system power loss in terms of generator powers, we have to define that total load current. So this is the individual load current, that is load one current, load 2 current, and load n current. So if you add this all load currents, then we will get that what is the total demand of current we are requiring from the load, right? Now this load, so I can write this entire load equals to ILK, and so here LK is a constant kth load constant LK. So actually ఎలా మన కరెంట్ ఎలా ఉందంటే the total load K is equals to, it directly proportional to that this value. If you this proportional constant is gives that how much of factor should be multiplied with this, then only it is both are equal. So that is given by the LK. Okay, now so here K is equals to 1 to n. So it based on that load bus 1, bus 1, bus 2, bus 3, like that. From this equation, LK can be written as IL. So this is the constant value. So if you find this LK value, then you can find that, you can get that how much of variable current is happening in the load. So andukani ikkada LK, so LK is a proportional load constant for obtaining the total load current. From this equation, we can get that LK is equals to ILK into ILK divided by ID. So this is equation number 16. So the total number of load currents is equals to the total demand required for the load current, and here ND is the total number of load buses. So ఇక్కడ వచ్చేసి ప్రతి ఒక్క లోడ్ రిక్వైర్మెంట్ కరెంట్ వచ్చేసి IL1, IL2 వీటన్నిటిని సమ్ చేస్తే టోటల్ గా ఒక లోడ్ నుంచి ఎంత కరెంట్ డిమాండ్ ఉందో చూపిస్తుంది. సో దట్ ఈస్ షోన్ బై ద ఈక్వేషన్ 14. నౌ దిస్ equation, the 14 should be both are equal to each other with proportionally. So equal ఎప్పుడు అవుతుందంటే we have to multiply with proportional constant that is given by LK, and LK is called as load proportional constant. Based on this value only, the both load total different load, sum of different load currents is equal to the total load current అనేది ఈక్వల్ అవుతుంది. ఓకేనా, అది ఎలా క్యాలిక్యులేట్ చేస్తాం అనేది ఇక్కడ వస్తుంది. LK is equal to ILK divided by ID, and it is denoted, represented as equation 16. Just note down these three equations. See, after found that LK value, now assume the bus 1 as the reference. So ఇప్పుడు మనకు ఏ బస్ టైప్ తెలియాలి. So we have three buses in the power system: slack bus, load bus, and generator bus. So if you know that a particular bus, then you can know that what is the known values and what is the unknown values. Okay, so andukani assume the bus. So we have the buses from 1 to n, right? In that, the first one I am considering that reference bus. So our reference bus is slack bus antar. Okay, now if you expand this equation, if you expand this voltage equation, V is equals to Zi with respect to the first column. ఇప్పుడు ఫస్ట్ కాలం అప్లై చేస్తే ఏమొస్తుంది, V1 equals to Z11 I1, Z12 I2. సో ఆ విధంగా వస్తుంది. సో దిస్ ఇస్ ద ఈక్వేషన్ we obtained from the V equals to Zi, and it is the first row of the equation. So this is the first row equation. Now if Ng is the number of generators and Nd is the total number of loads, the above equation can be written as. So ఇక్కడ వచ్చేసి ఈ వోల్టేజ్ ఈక్వేషన్ అనేది జనరేటర్ కి అండ్ లోడ్ కి సంబంధించి రెండు కంబైన్ చేసి రాస్తే ఎలా వస్తుందంటే V1 is equal to this term is belongs to the generators and this term is belongs to the loads. Why? Because I already said that. So previous మన LK కనుక్కున్నాం కదా. So K is equals to 1, 2, 3 and ND. So this is the number of loads. So here the first term is belongs to the generators and second one is belongs to the loads. Okay na. So ఎందుకు ఇలా ఈ ఈక్వేషన్ ఎక్స్పాండ్ చేస్తామంటే, first of all, if you want to find out how much of losses is happening in the transmission system, you should have to know that how many generation station is connected to the particular bus. Then only we can identify that how much of power is getting from the generating stations, and similarly how much of load is connected to the particular bus and what type of bus we have, slack bus or voltage bus or generator bus, like that. Now, after splitting this voltage equation for generator bus and load bus separately, in that ILK. So మనకు ఇక్కడ వచ్చిన LK is equals to ILK divided by ID. Okay na? So దీన్ని ఈ ఈక్వేషన్ నుంచి if you substitute ILK here, then you will get V1 is equal to summation. So entire time equation అలా వస్తుంది, ILK plus LK into ID వస్తుంది. ఓకేనా? సో ఇప్పుడు దీన్ని ఎక్స్పాండ్ చేసుకుంటే the final equation is this one. Here T is equals to summation of K is equals to 1 to Ng Z1K and LK. Here that T is called as load loss equation. లోడ్ లాస్ ఈక్వేషన్ ఎందుకు అంటామంటే ఇప్పుడు మనకు నెంబర్ ఆఫ్ లోడ్స్ ఉంటాయి. ఓకేనా? సో ఆ లోడ్స్ యొక్క పవర్ అనేది కాన్స్టెంట్ గా ఉంటుంది. అంటే మార్నింగ్ టైమ్ లో సమ్ లోడ్స్ వాంట్ ద మోర్ పవర్. ఈ ఆఫ్టర్నూన్ టైమ్ లో కొన్ని లోడ్స్ ఎక్కువ పవర్ కావాలి, ఈవినింగ్ టైమ్ లో ఎక్కువ కావాలి. సో బేస్డ్ ఆన్ దట్ we have to schedule that at what time how much of load we have to satisfy that. సో ఆ షెడ్యూల్ ని మనం సాటిస్ఫై చేయడానికి చేసే అది ఎలా కనుక్కున్నా అంటే బై యూజింగ్ దిస్ టీ ఫార్ములా. సో ఈ టీ వాల్యూ వచ్చేసి లోడ్ లాస్ ఫార్ములా అంటారు. లోడ్ లాస్ ఫార్ములా అంటే ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ డివైడ్ దట్ వన్ డే ఇంటూ 3 intervals 1 2 3. ఓకేనా? సో ఫస్ట్ ఇంటర్వెల్ కి సెకండ్ ఇంటర్వెల్ కి హౌ మచ్ ఆఫ్ వేరియేషన్ విల్ బి హ్యాపెనింగ్, 2 నుంచి 3 కి ఎంత వేరియేషన్ జరుగుతుంది. సో ఆ వేరియేషన్ అనేది మనకి ఇక్కడ నుంచి కనబడుతుంది అనమాట. సో ఎందుకంటే హియర్ ఇట్ ఈస్ క్లీన్లీ షోయింగ్ దట్ టీ ఈస్ ఈక్వల్స్ టు జెడ్ ఇంటూ ఎల్. అంటే జెడ్ ఇంటూ ఎల్ అంటే సో బేస్డ్ ఆన్ దట్ particular load, how much of power, how much of current it is dragging. So based on that, you can obtain that what is the current is obtained by the particular load, that is IL1 and IL2, like that we can obtain by using this equation, T equation. So represent it is equation 20. So until now we half of the derivation is over. We have few more derivations. So remaining ఇంకా మీకు 20 equations వస్తాయి. ఓకేనా? సో రిమైనింగ్ డెరివేషన్ వచ్చి మీకు రేపు క్లాస్ లో చెప్పేస్తాను. సో ఇంతవరకు యాక్చువల్ గా ఈ డెరివేషన్ వచ్చేసి కొంచెం కాంప్లెక్సిటీ అనమాట. ఎందుకంటే దిస్ డెరివేషన్ ఇస్ నాట్ కంటిన్యూస్ ప్రాసెస్. సో మీకు ఫస్ట్ ఈక్వేషన్ నుంచి కంటిన్యూగా వచ్చే కాదు ఇది. ఓకేనా? సో there are certain assumptions in between this derivation. సో you have to be must and remember that. ఓకేనా? మనం ఏ స్టెప్ లో ఎలా సాల్వ్ చేయాలి. సో ద మెయిన్ ఇంటెన్షన్ ఆఫ్ దిస్ ఫార్ములా is we have to calculate that power loss formula, that power loss with respect to the generators and loads. సో ఈ రెండింటికి మనం కంబైన్ గా కనుక్కోవడానికి ఇచ్చేస్తాం. మీకు డౌట్ అవచ్చు, ఆల్రెడీ మనకు కనుక్కున్నాం కదా, అంటే ప్రీవియస్ షెడ్యూలింగ్ మెథడ్ లో చేసాం కదా అంటే. సో దట్ ఈస్ ఫర్ ఓన్లీ జనరేటర్ బస్, అంటే జనరేటర్ బస్ ని షెడ్యూల్ చేయడానికి మాత్రమే కనుక్కున్నాం. కానీ ఇక్కడ వచ్చేసి లోడ్ కూడా ఇంక్లూడ్ అవుతుంది. So for different loads, so that's why we have to derive the particular manner power loss equation. Okay na? So this is about today's class. So previous problem chesara, are you completed what the previous problem, that is iteration method problem. See మీకు ఒకసారి ఆన్సర్ చూపిస్తాను, ఒకసారి చెక్ చేసుకోండి. సో రిమైనింగ్ ఇప్పుడు చూపిస్తాను ఎలా ప్రాబ్లం నెక్స్ట్ ఏం చేయాలని. సో ఇప్పుడు మీకు లాస్ట్ క్లాస్ లో చెప్పిన ప్రాబ్లం చూపిస్తాను, జస్ట్ చెక్ ఇట్ అవుట్ యువర్ ఆన్సర్స్. సో ఎన్ని ఇటరేషన్ వర్క్ చేశారు? హౌ మెనీ ఇటరేషన్స్ యు కంప్లీటెడ్? 1, 2 or 3? So I will show you that the final equation, final power loss equation. So this is the final iteration for that. In this case, the lambda value becomes so for fourth iteration you will get that balanced condition. So here in this condition the lambda value is 7.6789. If you assume this value, then you will get that PG, P1, P2, P3, P4, right? That is the value here, P1, P2, P3. And after substituting these values, you will get 0 here. And so after substituting this value, then you can find the total cost. So CT is equals to, we have 3 cost equations, right? CT equals to C1 plus C2 plus C3. So if you substitute in this equation, you will get finally 15.92.65. So this is the final equation of that what we explained in last class. So check just ఆన్సర్ నోట్ చేసుకోండమ్మా, తర్వాత మీరు సాల్వ్ చేయండి. Okay, wait, I will show you iteration wise. స్టార్టింగ్ నుంచి ఒకసారి చూపిస్తా వస్తాను, చెక్ చేసుకోండి. సో ఇనిషియల్లీ లాంబ్డా ఈక్వల్స్ టు 8 కన్సిడర్ చేసాము. తర్వాత P1, P2, P3 కనుక్కున్న తర్వాత, that is the first we found that P1, P2, P3 for first iteration we got the values here, this 3 51.3136, 78.5292, 71.157. After that we substitute in the power loss equation, we got 2.886. For balancing by using the balanced equation, after substitution of PL and P1, P2, P3, we got minus 48.1139. So it means that there is a updating of lambda value, and this is the process we did the lambda value, and the changing lambda we got minus 0.315. See after these two values, that is the updated value 8 minus 0.315, we got 7.6845. Okay, so up to now this is the first iteration. So ikkada nunchi meer second iteration start cheyali. So by using this lambda, again you have to find that P1, P2, P3 for second iteration. So you have to keep 2 like this. After form this equation, find the PL value and substitute then delta PK, that power balance equation. PD plus PL minus summation of these 3, again it is not equals to 0, then we have to proceed again. So ఇంతవరకు చేస్తారు కదా, నెక్స్ట్ రిమైనింగ్ చూడండి ఇంకా. So this is a second iteration. Here we are considering the lambda equals to 7.6845. ఎంతమంది సెకండ్ ఇటరేషన్ చేశారండి? ఓన్లీ యోగానందం. సెకండ్ ఇటరేషన్స్ వరకు ఎంతమంది చేశారు? How many of them completed second iteration? See, if you did this, see after second iteration, we will get that the power error is minus 0.8395. So again, you have to update that lambda value by using the delta lambda. Okay, so delta lambda చూడండి. So this is the lambda for updating the new lambda with respect to the third iteration, for the third iteration. ఓకేనా? సో ఈ విధంగా స్టెప్ బై స్టెప్ చేసుకుంటే వచ్చండి. జస్ట్ ఫైనల్ గా ఈ వాల్యూస్ వేసుకోండి, ఫైనల్ వాల్యూస్ వేసుకొని then you can get that clarity on this. So ఈ ఫైనల్ వాల్యూ వేసుకోండి జస్ట్. So here the lambda value is 7.6789. So just do this while substituting this value and find the P1, P2, P3. By using these three value, find the PL value and substitute in the power balance equation. Then if it becomes to 0, then find the total cost. So that you have to be do this. ఓకే, ఈ రోజుకి క్లాస్ చాలండి. ఓకేనా? సో రేపటి క్లాస్ లో వచ్చేసి రిమైనింగ్ పెండింగ్ ఉన్న డెరివేషన్ కంప్లీట్ చేస్తాం. ఓకేనా? సో మీకు ఆల్రెడీ మెటీరియల్స్ ఉన్నాయి, గూగుల్ క్లాస్ రూమ్ కోడ్ పంపించేస్తాను. సో యూ కెన్ గెట్ ఫ్రమ్ దేర్. ఓకేనా? సో లేదు సపరేట్ కావాలని పంపిస్తాను. Okay, so today's class is over. So I will continue from tomorrow class. Okay, so derivations ఒకసారి మళ్ళీ ఒకసారి చూసుకోండి, ఎందుకంటే రేపు కంటిన్యూ సెషన్ కి యూజ్ అవుతుంది. ఓకేనా? రైట్, థ్యాంక్ యూ, బై.